Greetings! Today, failed product special. So this is a power safer goodbye standby PSX power safe, should be power saver. Anyways, I picked this up in Poundland, and this came to my attention because this is not a product designed for Poundland. Normally in Poundland you'll find a ton of stuff that is built to a price, built to be able to make money on when you sell it for a single coin. But this stands out. Well, this stood out in the shop. So first of all, it's not made in China. It's made in the UK, or maybe it's made in China, and but the actual company has got a UK address, UK office in New Barnet, North London. Power Safer UK Limited. So yeah, it's got a UK and Germany office, UK and German office. And what this is, in essence, I think I saw a brief advert, or someone was talking about this somewhere on YouTube. Anyways, what this is meant to do. Oh, I think I know where I saw this. I think that was on Dragon's Den at one point. I think I might be wrong on that. Anyways, so what this is meant to do is, you know, when you put your TV in standby mode and just the little LED stays on, so whenever you come back from work you can just pick up your remote, press the power, and your TV comes on. Sorry. So this is meant to completely switch off, disconnect from the main supply, your TV, your I don't know, whatever else you have connected to it. I think the TV was the main idea behind this. And as you can see on the cover, there is a guy sitting on the sofa pointing a remote, and a very happy woman. So yeah, PSX is not suitable for computers or devices that use clocks and EPG. So basically what this means, that if you've got a set-top box set to record something at I don't know, at the time that you're at work, if you use this will switch the whole thing completely off, and it won't be able to come back on and start your recordings. Power supply 230 volts AC, 50-60 Hz, power consumption less than 0.5 of a watt, and switching capacity approximately 460 watts. So let's see. I've got a feeling why this didn't take off, but we'll get to it later. Let's get rid of the box, open it up. Okay. So it's a nice thick cardboard box, but we can put that aside. Some bubble wrap, that can go away. Look, you see it's got all kinds of different diagrams, how to connect it, so you can plug in an extension to it, and blah blah blah, because this has got only one socket. So yeah, we can put that away. So what we've got is, well, first of all, a proper UK plug. So this is unusual for a Poundland style equipment. This is fully compliant UK plug. So the mains is not the earth is not isolated, and there is required clearance and whatnot, and there is a fuse, and it's got the description on it, and the whole shebang. So yeah, proper UK plug, and the socket. Horrible security screws inside, but not a problem. Let's look at the cable. +1 mm Kenick BS 5500. Okay, anyways, so on the front it's got a there we go, just a protective film, and it's got a massive reset switch, a window for IR, I guess, infrared receiver, so it might work with some one of your remotes for a TV. Swivel base, so I don't understand why what's, oh, I know, so it doesn't tip over. You're meant to put it sideways, so it swivels only for the purpose of packaging it, so it fits in a smaller box. Anyways, let's have a look under the skirt and open this up. So we've got 4 rubber feet that come out in a usual way, and underneath we've got 4 Phillips screws. So let's go ahead with this. This product originally, I think they must have attempted to sell it at I don't know, 20-30 quid a piece, but it didn't take off. It's now in Poundland. When I was in Poundland, it did cross my mind just to get a bunch of them, the whole lot, whatever they have in store, and then sell them on eBay, because when I looked, they go on eBay for as much as £7 or £7.99. So I thought, hey, I can make a couple of quid on this, but then I thought to myself, nah, not really. So if I buy this for £1, eBay is gonna take a cut. Shipping is gonna cost me, what, Royal Mail, £2.80 these days for a small packet. So I'll be left with pretty much nothing. Especially if I wanted to sell them quickly, I would have to sell them for less than £7 or £8. So I thought, do you know what? It's not worth my time. But I took one just to have a look what's inside and make a video out of it. Oh, there we go. So first thing that comes off is the front bezel, which is this semi translucent black plastic. A switch that is see-through as well, kind of, and underneath we've got a little board with a soft switch, single color LED, and the infrared receiver, one of those box standard ones. It's a little bit bodged because the legs are bent a little bit, but anyways. Oh, why are you not coming off? Oh, this comes off first. There we go. Okay, base came off by itself without asking, so that's a good thing. The rest of the case, and we are in, and let's have a look what's inside. So now inside, what we can see is that we've got 2 cables coming in. Let me just unwrap this cable tie to make it somewhat easier. I'll have this hanging down. Okay, so we've got 2 cables coming in through a little bit stiff strain relief, but that's okay. And let's see which one's which. So the top cable is the output. So this is the output here. There is a relay, so this is how it does switching. You know what, let's take the board out of this. Okay, there we go. So single-sided board. Unusually horrible job with, or usually, as expected, I guess, horrible job with cleaning this up. Is full of flux residue, and I don't know, some of the joints are of a questionable quality, but nonetheless, let's have a look. What can we deduce from here? So let's try to work backwards. Why not? So where we go. So that's the relay here. So the relay gets a couple of volts from, well, 12 volts from here, and that goes into switching on the output. Now in the output there is this little transformer coupled in, and I think this is the bit that does sensing. So this is how this device knows that whatever's connected to it went into standby mode. So basically this transformer provides an isolated way of sensing whether there's any current flow. There is a fuse here, 2.5 amps. Now this bigger transformer here, this is a 9 volts times 2, 83 milliamps. So this is this provides supply for the rest of the electronics in this thing. And now, you know, transformers are an easy way of getting power onto something, but they are not the most efficient. This unplugs nicely. So this is meant to be a power saving product. Whenever your TV consumes, I don't know, let's say 2 watts in a standby, this is meant to eliminate that and basically turn it into 0, or I don't know, well, half a watt, whatever this is consuming. But you know what, if they'd done it as a switch mode, I would have thought that would have been a lot more efficient. But okay, they claim it's half a watt current, or half a watt power consumption in this unit alone. So let's trust them on this. So there's two. What the hell is this? PC817. They're little packages, 4-pin. They look like opto isolators, but I don't think they are. And you know what? If they are, there is no isolation underneath whatsoever. So what would be the point of a opto isolator in there? So I'm quite sure they're not. They're marked IC1 and IC7. So I'll look those up in a moment. That's LM358. Yeah, two LM358 op amps. There is a chip here with I don't know, serial number or version number or whatever that might be. So let's try to peel that off. $2051 EPs. Okay, so I need to look up what it is. Have a look at this cap. It's not an illusion. This cap has got quite a dent in the top of it. It looks as if maybe they didn't fit the case on properly when they were putting it together, or something fell on it. So I'm not sure how that affects device performance. But anyways, let's investigate what those chips are, and then have a look at why this failed as a product. And yeah, so I'll be right back. Okay, so after investigating, first of all, let's have a look at the chip that had the sticker on this. So the M2051EP. I did not find anything on this after having a quick look on Google, and all that comes up is the usual Chinese, Taiwanese and whatnot websites where you can order parts. You get the idea. So no actual data sheet on this. I'm not sure what it is actually. Looking at the back, there is quite a few pins unused. 1, 2, 3, 4, 5. Yeah, so it's what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 18 pin package. But 5 pins are completely not connected to anything. Is the custom chip? I don't know. I'm really guessing over here. Anyways, no idea what that is. Those little guys, they are opto-isolators, optocouplers, and why it really puzzles me. Why would there be an opto-isolator in here where well, first of all, there is no access to, the whole case is plastic and blah blah blah, so there is no access from for a user to touch the metal part and whatnot, and get electrocuted and whatnot. In fact, the only thing that comes in and out of this is the mains voltage, so I don't understand why those optocouplers are here. Especially the clearance. I mean, over here there is a track that's almost touching one of the pins of the coupler, so literally there is no clearance whatsoever. Normally when you have an optocoupler you would have a cutout or some separations. That's why you use them. So you want to isolate one side from another, where you're passing through some signal, but you want to make sure that in case of high voltage spike, it just doesn't get transmitted onto the rest of the circuit, and then through that onto a case and whatnot. But no, clearly that's not what they're doing here. Looking at the cable, so from the plug to the socket it was a one length of wire. So what they've done with the earth, it was a one length of wire. They just stripped it in the middle, and the earth just loops through from one cable onto the other, which is nice. So the earth is completely uninterrupted, and the neutral cables are just coupled in, all both input and output, so that goes through. So provided your sockets are wired correctly, this would be switching the live wire, which is the brown one. And yeah, I don't know, don't like that completely. I mean, they could have put a double pole relay in this, and that would have completely disconnected the device that's being controlled, but no, maybe it was too expensive. Anyways, oh, it was made in China. Look, the transformer, it's got a nice English description on the model XZF 900 100 blah blah blah, and underneath Shenzhen Xionging Electronic Factory. Yeah, so without a doubt, parts were sourced from the People's Republic of Everything Inexpensive. And at the mains input, so the live wire goes here. So on the back of the board, it goes straight into a fuse, and that fuse goes into into the relay onto the central pin. There is a reverse protection diode on here, so it doesn't blow everything else out when you're switching it through back EMF. But what else? Where is this transformer input? So the input of the transformer, oh yeah, so this is the primary side of the bigger transformer. So the mains goes also straight to this transformer. So this transformer is plugged in all the time, 24/7. So it's drawing some sort of current all the time. And yeah, that's all there is to it. The signal from the little transformer over here goes through those little tracks across. There is a couple of resistors here, a couple of diodes, and that goes into this LM358. So it's a double op amp, so clearly it's sensing what's happening with the current. If it's designed to see if something's drawing less than, I don't know, let's say 2 watts or 3 watts or whatever the case is, this would basically then think that yeah, it's in standby mode, and switch off the relay, completely kill the thing. This is the connector for the infrared diode. Now this might be some sort of custom chip or some box standard Chinese infrared receiver, this big one, and it's pre-programmed to receive what I think they might have done. It's pre-programmed all the infrared codes that have got power function, so anything that would switch on or off a device. So when this goes into the power or standby mode, it keeps awaiting for you to press power on the remote, and that's when it knows when to re-energize the relay, possibly. But yeah, nothing else over here. The output of the transformer goes through a discrete bridge rectifier, those miserable caps with a dent on the top, and that's all there is to it, I think, unless I'm missing something. But it's kind of straightforward contraption. But anyways, let's try to measure this up. I'm curious to see what sort of consumption does this take alone, and then we'll do some calculations. I'll try to make them simple, just to see why is this not working as a product, and why did it end up from being, I don't know, 20 or 30 quid in the shops down to Poundland and £7 on eBay. Okay, check this out. So I was about to put it back in the box so I can connect some meters to it, and I did mention somewhat dodgy soldering, and check this out. This neutral, the soldering was so shit, I can't say otherwise. It just popped out over here from the connector, well, the connector from the PCB, and even though there was some hot melt glue on top of it, it didn't encapsulate the wire. But as you can see, this still has got like a dome of solder on top of where the wire was, and the wire, it fits inside the dome. So that was really horrible soldering job. So potentially what would have happened with this, after if it was working for a while, I don't know, a couple of days, weeks, months, or whatnot, this connection, if you wiggle the cable loose a little bit, and this would have started arcing, and it would have created, well, effectively, it would have started a fire inside, and with a little bit of luck, it would have burned your house. So that's what you get from loose connections. But yeah, nothing too dramatic. We can fix that and proceed on to looking at the actual operation. Okay, so I've put this together after mending it by resoldering the wires where they should be in the first place, and I've plugged it into the socket just to see what it actually does when what it's supposed to do. So after plugging it in, I can hear a relay click. Oh, now it's turned red. So the LED starts blinking green for some time, and after a while it just switches over to red. Now I've tried testing the remote thing. So I've got Peel Smart Remote on my phone. The phone has got an infrared transmitter. You can see when I press a button, infrared diode blinks. I was using this to try to resurrect the UV box, but it didn't work. Anyways, when I press the remote, I'm pressing power on a random TV that I've got selected in this remote. Nothing happens, so it doesn't react to it. And you can press the button, the reset one, and the relay clicks in, and the LED starts blinking green. And in this mode either, it does not respond to any remote presses. So that's what it does. Anyways, let's get it under test. Okay, so the device under test is ready. Now, before anyone starts screaming, shouting and whatnot, so far this is unplugged. What I did over here, and I must insist, whatever you do, whatever you think, whoever you are, do not attempt what I've just done over here. This is a side effect of one of the days when the path of least resistance is too much effort. So what I've actually done is I've unscrewed the plug, opened the plug apart, removed the fuse from the plug and connected a multimeter instead of the fuse. So we should be able to measure how much current does it consume, this device. So yes, please do not try to do what I'm doing. If you do so, I am not responsible if you're gonna be dead, or if you get shocked, electrocuted, your house burns down, your cat dies, or whatever else that might happen. So first of all, do not even think about it if you've got any pets around you, because if your cat steps on this plug, your cat will become a light bulb for a brief moment. Anyways, so, or a dog, or a pet mouse. Yeah, so just please don't do what I'm doing here. Anyways, we've got the multimeter set to 200 milliamps. That should be enough in AC range, connected instead of a fuse through cables. Yes, so while I'm doing this, I'm gonna switch this whole thing on by plugging in the extension lead, this one here, which is coiled up over here. Now just plug it in. I'm committing myself not to touch the plug, the table, any of the wires. Let me just put this maybe in a slightly better position so we can see the LED maybe. Yeah, maybe that will do it. So yeah, I'm committing myself not to touch anything. I'll briefly wait for this to blink through all the available blinks until it starts blinking red, so we can that's when it engages and disengages the relay, and then I'm gonna unplug everything off from the socket and put it back together. So yes, actually one more thing with the multimeters, especially the cheap ones, and I'm not an expensive multimeter guy, just because it's got a range of 10 amps and 500 volts or however much it might have, it doesn't mean it's a good idea to stick it into 500 volts and measure 10 amps. just because the range is there, it doesn't mean that the device is actually safe to plug it into a socket or mains powered to high energy circuits, and yeah, those multimeters can explode quite violently in your hands and get you electrocuted and killed, and all in all it's quite unpleasant. So yeah, in this case I'm just leaving it as it is. Hopefully nothing will blow up. If it does blow up, it will make for a good video, so let's see what happens. Okay, it's in green LED blinking mode. You don't see the LED quite well, but it's consuming 5.4 milliamps. And let's wait until it blinks through the rest of the 5.2, 5.3. There we go, it's dropped to red and it's 4.8 milliamps, and I'm presuming it will stay like that. 4.9. So let's just reset it again, and it goes 5.3. So yes, that's interesting. Okay, I'm going to unplug this because it's a quite scary moment. Okay, back to safety. Okay, let's get this off. So it was 5.2, 5.3 milliamps in when the relay is engaged, and 4.8, 4.9 in when this goes into standby, which just suggests that it's not a really good standby mode, where there is hardly any difference between normal operation mode and standby, just for this device alone. But anyways, I'll just put this back together and we'll look at the actual consumption and how much could this device potentially save you money. Okay, so we've measured up anything between 4.8 to 5.3 milliamps depending on the state of the device. So for the purpose of working out what's happening, let's call it 5 milliamps. It's at 250 volts AC, so 250 volts times your 5 milliamps, that's 1.25 watts. Okay, so the box claims it's consuming less than half a watt, but this is more than double of what it claims. And you know what, possibly what I was saying earlier, if this had a switch mode power supply instead of the transformer, possibly that would have been doable, but with this this is not going to work. But anyways, this is what we've measured up, so it's 1.25 watts. Okay, so that is quite significant. So if the device is consuming 1.25 watts and your average TV, as I looked it up on the internet, between 1 and 5 watts depending on size, flavor, manufacturer, blah blah blah, let's call it 3 watts standby power for a TV. So what we've also just assuming that your TV is on for 3 hours a day, so that would leave with 21 hours in standby. So your TV in standby mode consumes overall 63 watt hours per day. So what we're doing with this device, we're actually not eliminating this, we are exchanging this into 24 hours plugged in to your socket, 1.25 watts, which would give 30 watt hours. So what we end up with, we are saving 33 watt hours, 33 watt hours of energy each day. So moving on, so different energy providers here in UK, they've got different prices, but from what I saw, on average is the price for electricity is 9 pence per kilowatt. So let's work this out. So that's in a day, 0. Yeah, 0.033 kilowatt hours, so 33 watt hours, times 9 pence, so price per unit, equals 0.00297. So rounding it up, we're ending up with 0.3 of a pence per day saving due to the use of this device. So based on this, if you've got one of those devices and you bought it in a Poundland, after 333 days roughly, if you're watching your TV only for 3 hours a day, you will get your money back. Okay, if you bought the device on eBay and you paid 7 quid, it will take you 2,333 days to get your money back of what you spent on this in electricity saving. Now if you bought this device some time ago and you paid full price for this when this was a new product, and you paid, I don't know, 20 quid for this in Currys or PC World or wherever that might be, that will be 6,666 days. So that's 18 years before you actually start saving money. So yes, if you bought this device some time ago, please make sure you do not unplug it after you got your money's worth in electricity saving. So yeah, obviously those numbers will change a little bit if you've got more devices plugged into it, but you can't plug in your set-top box, and those actually consume far more electricity than your TV. But let's say you've got a TV and a stereo and some other stuff. Okay, let's say you're saving 6 watts standby power or whatnot. Yeah, it's still gonna take you 9 years to get back your money if you paid 20 quid for it. And this is the fundamental reason why this product is junk. That's why it failed. That's why someone had a good idea, really, because it's not a bad idea. They've made a product fully commercial, finished and packaged and whatnot, and the idea seemed seemed good, but the product itself, it just doesn't work. It doesn't make sense. I mean, devices, home devices these days are quite good at preserving power in standby mode by themselves, and you know, this would have made sense maybe in the old days with CRT TVs and some other stuff, but in this day and age, yeah, it's a failed product. A shame, really. Somewhat nicely made, if not the dodgy soldering, but yeah, that's all there is to it. So thanks for watching. If you like the video, please do click like or subscribe for more videos, and that's it for this one. Take care.